So this will be episode number 3 of our Golang basics playlist. And in this playlist, we will be learning about interfaces, maps, and error handling in Golang. So we have a lot to cover. Let's jump right in. Let's open our VS Code first. All right, there we have our VS Code. All right. So in the last episode, we learned about structs in Golang. What are they, how to use it, and how to define a struct, etc., etc. So before we learn about interfaces, let's just create a struct first. Let's just understand what is the problem that interfaces are solving, right? So let's create a struct. Let's call it type shape struct. Okay, let's keep it empty for now. So structs can be empty. This is perfectly normal and valid syntax. Okay, so let's say we have a shape struct. And as we know, shape can be anything. Shape can be a circle, shape can be a rectangle, shape can be a triangle, etc., etc. Right? Now, whenever we are talking about a shape, a geometric shape, every shape has two things. One is the perimeter, and the second is the area. All right? Now, let's say we create a method for the area. Let's say func s of shape, because this is a method, so we need to define it this way. Let's call it area, right? So this just means, this is a method, this just means that this area function can only be called on an instance of a shape struct. That's what this means, that's it. Okay, so now the area will return the area of the shape. So whenever we are trying to return something from a function, we need to mention that in the function signature. So let's say if I try to return something now, let's say return 1, it is throwing an error. Why is it throwing an error? Too many return values. Why? Because this function signature has nowhere mentioned that we want to return something. This means it is returning void, not returning anything. So if we want to return something after the function, we need to mention it in the function signature. So we are trying to return 1, so let's just mention int over here. And now the error is gone. This is how you mention the return type of a function, if at all you want to return something. Secondly, one more point before we move on. So Golang functions are special. They're not like C, C++ or Java. They can return multiple values. So if I want to return, let's say an integer or a string, let's say hello, let's say this is the area. So we need to mention it in the signature as well. So whenever you're returning multiple types, you need to enclose them in a parentheses and then mention the second type. So you need to, as many values as you're trying to return, you should mention those many values in the function signature as well, right? Using the parentheses like so. This just means this function will be returning an int and a string. If I remove the return statement, the compiler will start throwing an error, missing return. Or let's say if I return just 1, it will still throw an error, not enough return values. So that's how returns work in functions, okay? Okay, moving on. So we know the area will return the area of the object or the shape. So for now, let's just return a hard-coded value of 100. So this 100 is the area of the shape, right? Let's just go with it right now. Shape can be multiple, I know. So for simplicity's sake, let's say this is a struct, and this struct has a method called area with which we calculate the area of the shape struct. Now, let's say if I have a function, function print area. This function takes an object of type struct, object of type shape, my bad, and then it prints the area of the shape. So we will do fmt dot println, and then what we do s dot area. That's what we do. And this way we can print the area of any shape that we are trying to work with. Now I want to print the perimeter as well, not just the area, because every shape has an area and a perimeter, right? So what if I want to print the perimeter? Can I do this? S dot perimeter? No, right? Because there is no method called perimeter that exists on the shape struct. The shape struct only has one method, which is the area. So if I need to enforce certain functionalities onto a struct, I will use the concept called interfaces. So interface is basically used to enforce a struct to implement certain functionalities. So what do I mean by that? So basically an interface is nothing but a collection of function definitions. Mind you, function definitions, not function implementations. Okay. So what do I mean by that? Let's see. So let's just remove this for now. And this will also throw an error. So let's just remove this for now as well. So we have a shape struct and we want this shape struct to enforce the shape struct to have at least two functions or two methods. One is an area and a perimeter. So let's first create an interface and then see how we do that. So type, let's call it shape interface. So again, the syntax is same like the way you would define a struct. You use the same syntax you use for interfaces, but instead of struct, you use an interface keyword like so, right? So now both of these look similar. So what is the difference? Before moving on, let's see what the difference between the two is. Because type shape struct has the same syntax, type shape interface has the same syntax. The only difference is interface keyword and struct keyword. So what is the difference between the two? So the first difference is you can actually create an instance of a struct, but you cannot create an instance of an interface. So let's see, let's create an instance of shape. So S is an instance of shape. And I can pretty much print this as well, right? But if I try to create an instance of this interface, it will throw an error. So let's create S2, which is shape interface. Now you see, it is not allowed. So basically you cannot create an instance of an interface. Interface in and of itself does not mean anything, but you can create the instance of a struct. So let's just remove this. This was the first main difference. Now, when I said what is an interface? So interface is basically a collection of function definitions. So what do I mean by that? So let's say every shape has two functions, area and perimeter. And what do they return? We can define the signature of this function in the interface. So let's call the first function as area. And the area will return the area of the shape, which is an int. And the second function will be perimeter, which returns the area, also perimeter of the shape, which is again an int. So this is what interface is. Interface is just a collection of abstract functions rather. If you're coming from Java or C++, you can say interface is a collection of abstract functions, which means just the function definition, but not the implementation, right? Now, how does this help us? Now, let's say I have a function which accepts a shape struct. Instead of passing the shape struct in the arguments, I can pass the shape interface. You can pass the interface and the arguments to a function. So let's see what I mean by that. Let's say we have a function which says print shape details. And firstly, it prints fmt.println. First, it prints the, and here, okay. So here in the print shape details, we will pass, earlier we were passing S shape. Instead of passing the struct shape, we will pass the interface, shape interface, right? So what is the benefit to this now? We'll see soon. So now we can do this s.area and s.perimeter, and it won't throw any errors, right? Remember, we were trying to print s.perimeter before it was throwing an error. So now it will not throw an error. So what does this mean? This means now I can do this in my main function. So I have a shape struct. I can simply do print shape details. I can pass in the S and it should work. But now it is throwing an error. And why is it throwing an error? Let's see. Cannot use S variable of type struct shape as a shape interface. So basically the compiler is crying to you about the fact that you have used the type as shape interface, but you're passing a shape struct, and the shape struct does not adhere to the interface. When I say adhere, I mean it does not implement the interface. So Golang does not have an implement keyword like in other languages. So what do I mean by implementing an interface or adhering to an interface? It just means that if that particular struct defines methods inside this interface, it will automatically implicitly implement that interface, or absorb that interface, or adhere to that interface. So right now the S is of type shape struct. So if I want to make it a type of shape interface, I need to implement all the methods in the interface. That's all that means. So the shape struct should implement area, the shape struct should implement perimeter, and then this error will go away, because once a struct implements or implements all the functions defined in the interface, it implicitly absorbs or adheres to the interface. I hope it makes sense. So let's fix this error first. So first we need to create an area method for this shape struct. How do we create methods? Like we learned in last example, we'll create func, open parentheses, type of struct, in this case shape, name of the function, area, and the return type is int. That's it. And let's return, for now, let's just return a hard-coded value, 100. Oops. Similarly, we need to implement the perimeter. See, the error is still there. It is not going away. So let's implement the perimeter as well, s.shape perimeter. And now it is an int and it returns 200. Now you see the error is gone. Even though you're passing a struct of shape, and in the function signature you are expecting a shape interface, but now the error is gone because the shape struct is implementing all the functions in the shape interface. This just means that the shape struct is adhering to the shape interface. The shape struct has implemented the shape interface. The shape struct has absorbed the shape interface. So there is no explicit keyword like extends or implements like in other languages. In Golang, if you basically define all the methods in the interface on any struct, that means the struct is absorbing that interface, or the struct is following that interface. So I hope this makes sense. This is how we use interfaces. And the benefit of interfaces is that you can enforce, let's say a practical example would be you are using a database and database connection object, and the database connection object needs to have a connect function, right? So let's say today you are using a Postgres database. Tomorrow you use a MySQL database. So instead of creating different structs for different database types, you will create just one interface, and then whatever type of database that you are trying to use, you will just implement that interface for your database, right? I hope it makes sense. And if it doesn't, please connect with me on Instagram. The link will be in my description and I will be able to help you. We can have one-on-one consultation calls as well if you have any more questions regarding the interfaces, right? Okay, I hope this makes sense. So let's move on to our map. So let me just comment this out, comment everything out here. Okay, so last time we learned about arrays, slices, and we learned about structs, right? So let's learn about maps. So what is a map? So map is basically the same as hash table or hash map in C++ and Java, or an object in JavaScript, or a dictionary in Python. It is the same concept. It is basically a data structure which has a key and a value. That's it, as simple as that, nothing too fancy. So let's see how to create a map. Again, we use the var keyword as usual. Let's call it my map. Now, to define the type of map, we use the map keyword. There's a keyword called map in Golang. And then after the map keyword, we use square brackets. Now, whatever type you mention inside the square brackets, it becomes the type of the key. So let's say we want a map of string and integers. Key would be string and value would be integers. So we can do this. Map string and then int. This just means the key will be a string and the value will be an integer. So in JavaScript, this would look something like this. If I see in JavaScript, it would be like this. Key, let's call it key 1, key 2, right? So This is what this means, as simple as that. Okay, so let me just remove this for now. All right, now this is just a declaration. Again, we have not allocated memory for it. This is just a variable, that's it. There's nothing inside of it. So how do we initialize an empty map? This is not initialization, this is just a declaration. So again, for maps, for arrays, for slices, whenever you're trying to declare them, initialize them, you use a keyword called make keyword. Make is used to initialize slices and maps in Golang. So let me just comment this out, and let me use the colon equal to syntax. My map colon equal to, use make, and the first argument that make takes is the type of object that you're trying to create. In this case, map of string of int, and the second argument is the size of the map. So if you give 0, well and good. Even if you skip it, it's still gonna be 0. So when you're trying to initialize a map, you can just give the type. You don't need to give the length. It's up to you. You cannot. It's up to you. All right. So this is your my map. Now let's feed some values into it. How do you do it? As simple as that. You use square brackets. Let's call it key1 equal to 1, 2, 3, 4, 5. Let's do it 5 times. 2, 3, 4, 5. Let's change the key as well. All right. Oops. Okay, so now your map has 5 keys. So let's try to print this map. Again, for printing slices, arrays, and maps, remember in the last episode we learned about the range keyword with the for loop. So again, in this episode as well, we will be using the for loop with the range keyword. So we use for, range, and then the name of the map. All right. So when we use range with a slice or with an array, it returns 2 things. First is the index and second is the value. But in the case of map, range keyword will return 2 things again. First will be the key and second will be the value in the map. So we can do something like this: key value colon equal to, and now you have access to both the keys and the values in the map. So let's try to print them. fmd.fprintf. The key is %s, again a placeholder value. This is formatted string. We learned about this in the first episode. Go check it out. And the value is %d, because this is an integer. So the first is key, which is a string. The second is value, which is an integer. Now if we try to run this, go run main.go. Yep, the key is key1 and the value is 1. Okay, let's just format it a little bit. It's looking very ugly right now. So let's just add a new line character. All right. Yep. The key is 1, the value is 1, the key is key2, value is 2. So it's working. So our map is working. So this is the basic example of how maps work in Golang and how you can iterate over a map, right? Okay, one more thing. So maps are not sorted. So just because we added them in a sorted order, this does not mean that the order will be maintained. So let's say if you have a function which changes this map in the future, the order might change. So this is not a sorted map. This is just a normal map. For sorted maps, you have to use something called as red-black trees, which is beyond the scope of this video for now. Maybe in the future when I make an advanced playlist, we can learn about that, but not right now. So this is how basic maps work. Now let's move on to our last topic, which is error handling, which is one of my favorite topics and most people have a gripe with error handling in Golang. Me personally, I don't. I love the way Golang handles error handling, and let's see what I'm talking about. So let me just comment this out. All right. Now we just saw that functions can return some values, right? But functions not only return values, in Golang, we don't have a try-catch block like in other languages. So in the way Golang handles error is, Golang expects that whenever you call a function, if there is a possibility, if there is a propensity to throw an error, it should be handled on the very same line that you are invoking the function or that you're calling the function. So what do I mean by that? So basically in Golang, every function which has the capability to throw an error can return the error itself as a return statement. So let's see. Let's see, I have a function called sum, right? Sum is a very simple function. It will take two arguments and it will return the summation of those two arguments. So it just, let's take two, or rather, no. Let's take division. Division will be easier to understand. Sum is okay, so we'll come back to sum later. So division, it will take two arguments and then it will return the division of those two numbers. So let's say it takes a and b, which are integers, and then it returns the integer, which is the result of the division. Return a by b. That's it. Now this is a simple division function, but there is one edge case here which can throw an error. So in mathematics, division by zero is undefined. Similarly, in computer science, if you try to divide a number by zero, it is undefined and it throws an error. So you need to handle that edge case. Now, how do you handle that edge case? How do you throw an error in Golang? So let's see. First of all, if your function can throw an error, it should have that in the function signature, that this function can throw an error, so it should return an error in the function signature as well. So this function can either return an int, and it has the possibility to return an error as well. So this is how you return errors from a function, right? Now you see this is throwing error, not enough return values. So again, we are returning just int, we are not returning the error right now. So we need to check, we need to have an if condition. If the b is 0, in that case we need to return an error. So let's see how to do that. If b equal to 0, okay, so in Golang again we have if-else statement. Sorry, I did not teach you this earlier, but again, just like any other language, Golang also has if-else statements, and again, it does not require parentheses. So you just write if and the expression and then curly braces. So if b is equal to 0, in that case, division will be impossible to do because it is undefined. In that case, we will throw an error from this function. So we will return, let's say 0, and then, okay, so when you have a return called int and error, always you have to return both the values. There are no optional returns. So even when there is an error, you should at least return 0, and then the second return will be the error itself. How do we return the error? We use error dot error, and inside of this, oops, okay, my bad, not like this, fmt dot error f, yeah, cannot divide by 0. All right. So this is how you handle errors in Golang. So basically, if b is 0, the int value will be, let's say, 0 in this case, or any garbage value, and then the second return will be the error itself. This is how we are returning the error using the fmt package. So this will just return the error. And now you can see the return statement is still throwing an error. So again, we are returning just the division result, not the error itself. So, but if b is not 0, that means the division is valid. So when there is a valid division and we have no error to return, we can just return nil. So if you have no error to return, just return nil. Nil is just like null pointer in C++ or C. Sorry, null is just like null pointer in C++. Nil just means anything that is not nil valid, that is basically does not exist, right? So this is how you can return a nil error, and this is how you return the actual error. So let's try to test this out in the main function. So in the main function, let's call division method. Let's give it 1, 2. Let's give it something rather better, 4, 2. So go run main.go. I need to print this. Sorry, my bad. I need to print this as well. fmt.println. Okay, let's see what happens now. As you can see, it is returning 2, which is the result of the division, and the error is nil. All right. Okay. If I do this 4 by 0, 0 and cannot divide by 0. So it is giving me the error as well. But there is one thing that you need to understand always. Do not do it like this. Never use this way. Whenever you have a function which throws an error, you need to handle that error. So let's say if I call a division, let's say 4 comma 2, right? So you can see it throws an integer and an error. You always need to handle the error. How do you handle the error? Basically storing the value in a variable. So let's say this is value and the second would be an error. Let's call it error. Now you've stored both the values. Now you need to check whether this error is occurring or not. So how do you do that? If condition, if error is not equal to nil, that means there is an error has happened. You just do fmt.println error or whatever you feel like, however you feel like handling. So this is one of the most common syntax of error handling in Golang, and you will see this pretty much everywhere in most of the code. Actually, in every code you will see this. And if there is no error, you just println the value like so. So this is how you handle errors in Golang whenever you're trying to implement error handling. Okay, so this is one syntax. There is one more syntax. Let's take a look at that. So either you can do it like this or you can do it like this as well. Let me just comment this out for now. You can do it like this as well. Value, error, and colon equal to division 4 comma 0. Right. If you want to handle this in one single line, if you don't want to write this if condition on a different line, you can do it like this as well. You can write if over here, if value comma error, and then a semicolon, then check if error is not equal to nil, then you can do fmt.println value. So what does this single line syntax means? This just means the same thing that you're seeing over here. So this and this are same. We just moved this entire thing onto the first line. So if value error is division.4 and then a new line, semicolon means the end of the statement, then error is not equal to nil, then just print the value. Or if you want to check the error, if error is not equal to nil, that means there's an error, my bad. That means there's an error, so you print the error. And if this scope does not execute, then you can just print the value. Like this. Okay, one more thing. So your scope is defined till here only. So this value keyword, let me just console this one out. So this value is not available outside of the scope. So remember, whenever you're using this single line format of error handling, whatever you define inside the if block is not available outside of it. So this value is undefined because this value and this value are different. This value is only defined within this block. Okay, so yeah, so let's just remove this. And let's say you don't want to use some returned value from a function. Let's say in this case, you don't want to do anything with the value. So if you don't want to do anything with the value, you can just do underscore. So whenever you write underscore, that means this argument is not going to be used, so don't bother with it. So that's what this underscore means. So the error is gone now, and this is how you handle the error. So we have another package called log. You can just log the error, log.fatal. Why is it not working? Fatal, oh my god. Yeah, and then you can just print the error. So this log.fatal basically shuts down your process and exits the code. So this is one of the way of handling errors. There are other ways as well, like panic and recover. We will see them in some other episode, maybe in the future. But for now, this makes sense to me, and I think this should be enough for today, and then we can continue with the next episode later.